Okay, so you guys have sent us some really wild stuff this time. We're
Yeah.
diving deep into the Earth's catastrophe cycle.
Right.
Which is this idea that, the really big global disasters,
Yeah.
maybe they aren't just random, maybe they're part of some kind of
Mm-hmm.
a cycle, something that happens over and over.
Right.
And to make things even more interesting, you've thrown in some pretty heavy stuff, like potential CIA cover-ups and these things called solar micronovas.
Yeah. Fascinating stuff.
So our mission today is to go through all of this information you've given us
Right.
and figure out what's really important, what you need to know.
Absolutely.
So you've given us a lot to think about.
Yeah.
We've got YouTube videos with transcripts,
Yep.
a podcast outline. Seems like a lot of different perspectives on these big questions.
Right. Like, is the Earth really on some sort of a timer for these huge disasters? What is the role of this galactic current sheet? What about the sun? And is it really going to have these massive outcomes?
Right.
And then, of course, the biggest question, was there a deliberate effort to keep all of this quiet, to keep it a secret?
Okay, so let's start with that cover-up idea first.
Right.
Because one of the sources talks about a really surprising timeline.
Yeah.
And it's not just about Chan Thomas's book being hidden by the CIA,
Right.
but the idea that the government knew something big about the Earth way back in the 1940s.
In the 40s. Wow.
That's pretty far back.
It is. This whole story centers on Major Maynard E. White.
Okay.
And this project, Project Nunnik, which was a government mission up to the Arctic.
See, Arctic. Okay.
Now, the official reason for the mission was the Cold War.
Okay, yeah.
They said they needed to figure out exactly where the magnetic pole was.
Right.
For strategic reasons, all that Cold War stuff. But this account we've got suggests that they actually found something way more important than just the pole's location.
Really?
Something really big.
Interesting. So they went to the Arctic to understand the landscape, I guess.
Yeah.
And they ended up finding some unexpected geological secrets.
That's what it seems like. Major White's team.
Yeah.
They found out that the magnetic pole wasn't actually fixed in one place.
What?
Yeah, it moved.
Really?
And they connected this movement to these recurring disasters that happened on the planet.
Okay, now this is where it starts to get really wild, right?
It does. We're talking about finding tropical coral way up north in the Arctic,
Wow.
and these strange layers in the Earth's geology.
Okay, so what did they think all of that meant?
Well, their interpretation of these tropical fossils in the Arctic
Yeah.
and the weird layers in the geology
Yeah.
was that the Earth actually experiences these massive shifts in its poles.
But the whole planet tilts.
Yeah, like the entire planet flips over dramatically.
Wow.
And they thought that this happened on a cycle of about 12,000 years.
12,000 years, okay.
But here's the thing. They originally thought they saw evidence for 9 separate disasters.
9.
Yeah, 9. But they later decided that it was more likely just 5 really big ones.
Okay.
They figured one of these events was so massive that it caused so much geological chaos, it looked like several smaller disasters.
So 5 events in roughly 60,000 years.
What?
With about 12,000 years between each one.
Exactly.
And their main point was that these weren't slow, gradual shifts, but really fast flips.
Yeah, that's the key. They were saying the Earth's axis flips quickly, and this is important,
Yeah.
it flips back to the original polar position.
Oh, so it goes back to where it was before.
Yeah, eventually.
Oh.
And that would explain why we see evidence of ice caps at the North and South poles over really long periods of time.
Okay, yeah, because the poles basically return to the same spots, even if they move around in between.
Exactly.
Okay, so that's Major White and Project Nunnik.
Right.
But now we have to talk about Charles Hapgood.
Yeah, the OSSCIA geophysicist.
Right. He seems really important to this whole idea of a hidden truth.
He does. Now, publicly, Charles Hapgood was a professor, right? But he was also working for the government, behind the scenes.
So like a double life kind of thing.
Sort of. And the interesting thing is, his classified research seems to have aligned with what Major White's team found.
Really?
Yeah, it supported the idea of these quick, complete pole flips happening every 12,000 years or so.
Okay, but didn't he also publicly present a totally different theory?
He did. This is where things get a little confusing.
Yeah, this is the Earth's crust displacement theory.
Right. In this theory, he suggested that the Earth's outer layer, the crust, that it shifted slowly and in smaller movements over very long periods of time.
Okay.
And crucially, without that return to the original poles.
Oh, so a very different picture from what he was supposedly working on secretly.
Exactly. And your sources point out that this public theory was actually debunked by other scientists later on.
So are we saying that maybe Hapgood's public theory was intentionally misleading?
That's the implication, yeah.
Like, he was trying to discredit the idea of rapid Earth changes.
That's what some people believe.
Wow, that's a pretty big claim.
It is. By putting out a theory that was easy to disprove, it might have made anyone else talking about rapid Earth changes look less credible.
Like they were all conspiracy theorists or something.
Exactly. And that would have been a convenient way to keep those earlier, potentially more accurate findings under wraps.
And then you've got Chan Thomas trying to publish his book, The Adam and Eve Story, which gets classified by the CIA.
Right.
It really starts to look like a pattern of keeping this information hidden.
It does.
And the story about Major White becomes even more important.
Right.
Because if it's true, it means Hapgood knew about those rapid flips and the cycle of disasters from his secret work. But he told the public a completely different story.
Yeah, and that raises a lot of questions about why he did that.
And how deep this whole cover-up goes.
Exactly. And one of the sources, the book Cosmic Disaster, it goes into detail about these efforts to hide or reveal this information.
To control what people know.
Right. It's like a battle over the truth.
Okay, so we've got this potential government cover-up, but now let's switch gears a bit and talk about the actual science.
Okay.
What is this galactic current sheet that keeps coming up?
Yeah, the galactic current sheet, it's kind of hard to imagine, but
Yeah, it sounds pretty out there.
it is. Imagine our galaxy, the Milky Way,
Yeah.
not as just empty space, but as having this huge but almost invisible layer of stuff.
Darth.
Yeah, electrified particles, dust, and magnetic fields.
Like a giant sheet running through the galaxy.
Exactly. And it's not smooth, it kind of ripples and waves.
Wow.
You can almost think of it like the galaxy's equator.
The galaxy's equator, okay.
Yeah. And our solar system, as it goes around the center of the galaxy,
Over millions of years, right.
right, over millions of years, it periodically moves into and out of this sheet.
So we're like bobbing up and down through this sheet of galactic stuff.
Yeah. That's a good way to think about it.
Okay, I think I'm starting to get it.
To make it a bit easier to understand,
Yeah.
you can compare it to our own sun.
The sun has a current sheet.
It does. It's a region around the sun where the magnetic field kind of flips its direction.
Oh, okay.
So the galactic current sheet is like a much bigger, denser version of that.
But it's not just charged particles, right?
No, it's got plasma, gas, and a lot of dust too.
And how does all of that affect the Earth?
Well, the idea is that when our solar system moves through this denser region of the galaxy, all this extra stuff and the electromagnetic activity, they interact with the sun.
Okay.
And these kinds of encounters are thought to trigger something called novae in other stars.
Novae.
Yeah, it's when a star suddenly gets much brighter, like a huge outburst.
Wow.
And the theory is that our sun might experience a similar outburst, but maybe on a smaller scale.
A solar micronova.
Right. And these micronovas might be triggered by our trips through the galactic current sheet, happening every 10,000 to 15,000 years.
So, like clockwork, we get hit by this wave of galactic stuff.
Right.
And it sets off the sun.
That's the idea.
Okay, so what's the evidence that this has actually happened?
Well, your sources outline 5 main pieces of evidence that point to these solar micronovas.
5. All right.
First, we see mass extinctions in the fossil record.
Mass extinctions.
Yeah, lots of different species suddenly disappearing.
Oh, like the dinosaurs?
Exactly, and that could definitely be caused by a huge solar event.
Okay, that makes sense. What's the second piece of evidence?
The second is what's called the glaciation paradox.
The glaciation paradox, okay.
Basically, we see evidence in the geology of these rapid, widespread ice formations.
Ice ages.
Yeah, but to get an ice age, you first need a lot of water vapor in the atmosphere.
So something has to evaporate a lot of water first.
Exactly, and that means a huge heat source.
Okay, so lots of heat, then a sudden freeze.
Right. And a solar micronova could explain that. The micronova's initial burst would create massive amounts of heat, evaporating water everywhere.
Oh, okay.
But then all the dust and debris from the micronova would block out the sun,
Oh, I see.
causing a long period of global cooling.
So a sudden bake, then a deep freeze. Yikes.
Yeah.
What about the other pieces of evidence?
The third piece is the record of magnetic reversals.
Reversals.
Yeah, and big changes in the Earth's magnetic field.
Okay.
These seem to happen at the same time as the disasters we've been talking about.
So maybe a connection there.
Right. A strong electromagnetic field from a solar micronova could be powerful enough to actually flip the Earth's magnetic poles.
Oh.
And the fourth piece is the impactors.
Impactors, what are those?
It's the debris, the small meteors and stuff that hit the Earth during these periods of upheaval.
Okay.
A big solar outburst could send all sorts of objects in our solar system flying off in different directions.
And some of them would hit Earth.
Exactly.
And the fifth and final piece of evidence.
The fifth piece is the presence of these weird isotopes.
Isotopes.
Yeah, they're like special versions of atoms.
Oh.
And we find them in these tiny glassy particles called microtectites.
Microtectites, okay.
And also in fossils from these time periods.
So strange isotopes from a long time ago.
Right. And these isotopes are really hard to explain if they just came from asteroid impacts.
Really?
Yeah. The way they're made and how quickly they decay suggests they came from somewhere closer and more recent.
So not from some random asteroid.
Right.
But from
our sun.
Our sun.
Yeah. It's really hard to imagine how dust and isotopes from other stars could get to us in the right amounts and at the right time.
So a solar event makes more sense.
Exactly. A local solar event.
Okay, so we've got these 5 things. Extinctions, the sudden heat then cold, the magnetic flips, the impact debris, and the strange isotopes.
Right.
And they all point to a solar micronova.
Yeah.
Which is caused by our solar system moving through the galactic current sheet.
Precisely. It's like a chain reaction.
Wow, that's a lot to take in.
It is.
So what about now? Are there any signs that we might be heading into another one of these cycles?
Well, this is where it starts to get a little unnerving.
Oh?
Because right now, the Earth's magnetic field is weakening.
Weakening.
Yeah, and it's shifting faster than usual.
Oh, wow.
The magnetic poles are moving pretty quickly.
Really?
And the overall strength of the magnetic field is going down.
Okay, and some of the sources say that we're already pretty far along in this shift.
Right. Maybe as much as 150 years into it.
150 years, that's a long time.
It is. And there's some other stuff happening out in space that might be connected too.
Like what?
Well, there have been these observations of changes in Pluto's atmosphere.
Pluto.
Yeah. And increased flaring from Proxima Centauri and Barnard's star.
Those are
2 of our closest neighboring stars.
Okay.
And they're in the direction of the galactic center, where this current sheet is.
So maybe they're being affected by it.
That's the thought.
And if they are, does that mean our sun might be next?
It's a possibility.
So it could be like an early warning sign for us.
It could be, but it's really hard to say for sure when or how strongly this galactic current sheet will affect our solar system.
Right, because it's not like a perfectly straight line or anything.
Exactly. And different stars will react to it differently.
So it's hard to predict exactly what will happen.
It is. Some people think it could be decades before we see any major effects.
Decades.
Yeah, maybe even a century.
100 years. Okay.
But the strange things that have been happening with the sun lately, they definitely make you wonder if something bigger is on the way.
Yeah, that's pretty unsettling.
It is.
And there was this one source, Chan Thomas's classified book,
Right.
which predicted that the next polar regions would be the Bay of Bengal Basin and the Pacific Ocean near Peru.
Yeah, pretty specific predictions.
Yeah, so is there anything happening right now that even remotely lines up with that?
Interestingly enough, there are some reports of the north and south magnetic poles converging in the eastern Indian Ocean.
Really?
Yeah, and that's pretty close to the Bay of Bengal.
Wow.
And at the same time, there's a weak magnetic point opposite the south magnetic pole near the Bermuda Triangle,
Bermuda Triangle, okay.
which is, geographically speaking, in the vicinity of the Pacific coast of South America.
Kind of near Peru?
Kind of, yeah. It's definitely a curious coincidence.
Yeah, very strange.
But we have to be careful about jumping to conclusions.
Right. One observation doesn't prove anything.
Exactly.
So, if these big catastrophes are really cyclical, how did humans survive them before?
Well, there's evidence that people saw shelter in caves and maybe even built underground structures.
To escape the disasters?
Yeah, like a safe haven.
Wow.
And your sources also mentioned these government underground facilities.
Oh, right.
Though they might have been built for different reasons originally.
Right, like for the Cold War or something.
Exactly.
But the point is, people did survive these cycles, otherwise we wouldn't be here.
Exactly. Our ancestors are pretty resilient.
They had to be.
They did.
Okay, one last thing I want to touch on is this whole pseudoscience label. Why is it that this idea of a recurring catastrophe cycle is often dismissed as pseudoscience?
Well, your sources suggest that a big part of the reason is that Charles Hapgood's public theory, the one about Earth's crust displacement,
Yeah,
it was pretty easily debunked.
right? We talked about that.
And because his version was flawed, it kind of made the whole field of catastrophism look bad.
Like they were all crackpots.
Yeah, unfortunately.
And that might have helped to keep the more accurate classified information hidden too.
It's possible.
So, because of a bad theory and maybe some deliberate suppression of information, this whole area of study got labeled as pseudoscience.
Right. And it's important to remember that the evidence we've been talking about today, it comes from real science. From geology, paleomagnetism, astrophysics.
It's not just made up stuff.
No, it's based on real data and observations.
So it deserves to be taken seriously. Okay, so as we wrap up this deep dive,
Yeah.
what are the key takeaways you want our listeners to remember?
I think the most important thing is that the Earth seems to have a history of cyclical disasters.
Right.
And these disasters might be linked to our solar system's journey through the galaxy and its interactions with this galactic current sheet,
Okay.
which could trigger these massive solar events like micronovas.
And there's a lot of different evidence pointing to this.
There is, from the geological record to the changes in the Earth's magnetic field to those unusual isotopes we talked about.
And the changes happening to our planet right now with the weakening magnetic field and all that,
Yeah,
that might be a sign that we're entering another active phase of this cycle.
it might be. It's hard to say for sure, but it's something to keep in mind.
It's definitely a lot to think about.
It is. But I think understanding the possibility of these long-term cycles helps us to make sense of the changes we're seeing both on Earth and in our solar system.
It gives us a bigger picture. So, as our listeners process all this information, what's one final thought you want to leave them with?
I would just encourage everyone to keep learning about these things,
Yeah.
to think critically about what you read and hear,
Right.
and to come to your own conclusions. Don't just dismiss these ideas out of hand or let fear take over. There's always more to learn.
Always.
And the history and future of our planet might be much more complex and amazing than we realize.
It's a pretty humbling thought.
It is.
Well, thank you for taking us on this deep dive.
You're welcome. It was my pleasure.
And to our listeners, keep those questions coming.
Absolutely.
Until next time, stay curious.